Good morning, everybody. Let us start with this question number 15. I think
Yes, sir.
we have done it. Okay. So what is the answer? You got the answer?
99 into 10 power minus 4.
99 into 10 power 4. Very good. So what is the approach of solving the problem? Please enlighten me.
I wrote both equilibrium reactions and then H plus will be 10 power minus 6. So I written that as Y plus A. Y is contribution from HA minus and A is contribution from acid.
Okay. So you have written like H plus is equals to 10 to the power minus 6. How do you know this?
We need to reach that point finally
Yeah.
after addition of acid.
After the addition of acid, H plus will be this. Okay. Good. After the addition of acid, H plus should be equal to this. And how you are so sure about this? That after addition of H plus, this will be the pH, that will be the H plus ion concentration.
We are adding acid so as to reach 10 power minus 6. So it should reach 10 power minus 6.
Okay, your answer should be, since we are heading towards isoelectric point. And what is isoelectric point? Since we are heading towards what? Isoelectric point, isn't it? So we have not been at the isoelectric point. We have been, our H plus ion concentration was what? Less than isoelectric point. Wherever it was, must be less than isoelectric point. Am I right?
Yes, sir.
So why it is less than H plus isoelectric point? You got this. The important thing is to understand the funda. Why we are less than isoelectric point?
Because A2 minus was less than, A2 minus was more than H2A.
Yeah, because if our acid is, I will take the amino acid like HA negative. I will take it like HA negative. This is my amino acid. Okay. Why? Because our amino acid should look like H2, H2A. How come? Glycine, CH2, NH2, COOH. So just protonate it and this will become CH3NH3 plus. So right now, this is a cation species, but this is basically, we can take it as 2H2A. Okay. Now, if it is going to lose one H plus ion, so one H plus ion, it definitely lose from here, So that will become CH2, NH3 plus and COO negative. Okay. So this is going to be what? HA negative. All right. So we can say that H2O is changing into what? HA negative. So you have added HA negative in water. That is the idea. Since you have added HA negative in water, this HA negative in water is going to do what? HA negative is going to do two type of things. I have already hinted in the last class that HA negative can lose one H plus ion and it will become A2 negative plus H plus ion, or HA negative can gain one H plus ion and that become H2A plus OH minus. So these two things happens when you add amino acid in water. You call it an amino acid. This is amino acid. So when you add in this water, this happens. Now what is happening? Since pH is greater than less than 6, less than 7. So you are confirmed that H plus ion concentration is greater than OH minus ion concentration. In that scenario, we would say that A2 negative ion concentration is more than H2A concentration. And A2 negative is anionic species and this is cationic species. You understand? But definitely anionic is more than cationic, so it could not be isoelectric point. So I'll already explain this. It could not be isoelectric point. Once you are sure that this is not isoelectric point, so you are guessing that your guess is that pH is equals to 6. That guess is wrong. Okay, that guess is wrong. So in fact, what is happening? You are ahead of it because you think that pH is equals to 6. No, pH is basically equal to 6 And at isoelectric point, A2 negative should be equal to what? H2A. If that is the case, so you want to reach to isoelectric point, you have to make this A2 negative concentration slightly less. To make this A2 negative concentration slightly less, you have to do what? You have to add H plus ion. So that means you are ahead of the isoelectric point. You are right here. And isoelectric point is here, and this is at pH is equals to 6. So that is I explained in the last class. Okay. So what you need to do, you have to add some H plus ion into this one. Once you decided that, then the problem is very easy. But only thing is that you have to ascertain this. Now problem is very easy. Do you heard of the charge balance?
Yes, sir.
So you apply here charge balance. You can also do it by some other method, but you can apply here charge balance. So according to charge balance, you know what is the idea? The idea is that at equilibrium, the H plus ion concentration plus whatever cation is there, uh, cationic species like H plus ion is there, that must be equal to cationic species, and cationic species should be what? If you're adding glycine into this one amino acid, there is no cationic species because this is Ha negative, and Ha negative is changing into A2 negative plus H negative. So this is a neutral ion. So cationic species is when it is going to take one H plus ion. So that is going to be what? H2A. That must be equal to what? OH negative plus the anionic species, and which we call it what? A2 minus whatever it is, and plus the addition of acid. You have added something like HCl. So I would write here Cl negative ion concentration. Try to understand this. Let me make it more clear. This is CH2, COO negative, and NH3 positive. This is our amino acid, and it is going to change into CH2, COOH, and NH3 plus. We will call this cationic species. And similarly, this is going to change into CH2, COO negative, and NH2. This is, we are going to call it anionic species. Okay. So the concentration of this and concentration of this should be equal. So I would like to write H plus plus the cationic species. Should I call it A plus? That must be equal to anionic species. Should I call it A negative plus OH negative and plus Cl negative? That's it. This is how I would like to solve this problem. Now H plus ion concentration is surely when A positive is equals to A negative. At that point, H plus ion concentration is surely equal to what? 10 to the power minus 6. That means OH negative concentration is equals to what? 10 to the power minus 8. So if I substitute in this equation, then we have 10 to the power minus 6 plus A plus whatever it is equals to A negative whatever it is plus OH negative whatever it is and plus Cl negative. Now this is going to cancel. So you are left with 10 to the power minus 6 is equals to 10 to the power minus 8 plus Cl minus. And this gives you the Cl minus concentration is equals to 10 to the power minus 6, 1 minus 10 to the power minus 2, which is 0.99 into 10 to the power minus 6. This means Cl negative at equilibrium is equals to 0.99 into 10 to the power minus 6 m. Now you have added some water into this one. How much water has been added? 10,000 liters water. So what amount you have added? So definitely whatever amount we have added, let's suppose that X moles have been added. divided by 10,000 liters is equals to this concentration 0.99 into 10 to the power minus 6. So this x is equals to 0.99 into 10 to the power minus 2, which is 10 multiplied 10 divide 9.9 into 10 to the power minus 3 mole must be added, and that is equals to 9.9 millimole. Have you done it like this? Or there was some alternative approach?
I did calculation I did using that XY approach. C minus X,
XY
C minus.
approach. Okay. You have done it by C minus X approach. But isn't it, this is very easy? If somebody is going
Yes.
to ask you, that is going to be asked you in this format. Okay. Once your idea is clear that you are ahead of the isoelectric point, you can easily do it. Done? Very good. If you have done it. You have taken help from anybody? You done it on your own
On my own.
with Prakash? That is good. So you have, I'm very much interested, pretty much interested in your method also, because I've shown you my method. Why not you just give a photograph to Prasad ji and I will discuss it. That's fantastic. I will also come to know about your methods, how you're going to solve this problem. Okay. So have you done it on rough pages? Share it. I think very interesting. If you have done it, because it will consume a lot of time. Otherwise, I will also discuss the method you have solved the problem. That is also a very nice method. But I think this is a very easy question. And if it is an easy question, then it can be asked in ITJ, something like this. This approach is very important, not this important. This question per se is not very important. See the approach and how to use this charge balance condition, and especially in isoelectric conditions. Okay. So this is the idea. Now, Ved Prakash, I will ask you this question because very interesting. You are speaking. So I will just, how do you know so sure that isoelectric point is pH is equals to 6? Why are you so sure?
If I write equilibrium equation for both reactions and
Yeah.
put the condition that HA minus is equal to A2 minus.
Good. Very good. Fantastic. Because we know if amino acid could be written like this, like, I always take amino acid to be simple amino acid to be H2A. Okay, it's like a dibasic acid. And then from dibasic acid, you get HA negative. And from this, you get A2 negative. So that you can compare this question with this simple dibasic acid case. Okay, let's call this K1 equilibrium constant. Let's call it K2. In fact, we call it K1 and we call it K2. Okay, so you're absolutely right. At isoelectric point, one thing is sure, these two species are going to be the same in concentration. So, in these equilibrium, K1 into K2 must be equal to concentration of H plus whole square into concentration of A2 negative divided by concentration of H2. Absolutely right. Since our condition of isoelectric point is A2 negative, must be equal to H2A. So they are going to cancel, and neat and clean you will get H plus is equals to under root of K1 into K2. So you're absolutely sure that isoelectric point pH will be 6. And now you come to know about it. pH at isoelectric point exactly 6. And pH at neutral point is greater than 6. We need to add H plus ion to get to isoelectric point. So that was the conclusion of this problem. Okay, done. Good. And I'm pretty much interested in your method as well, because methods are more important. It's not that why I'm discussing a question. If you really want to get hold of ionic equilibrium, your method, and I can understand what you have done. I can understand what you have done. So share it. If it is possible, I will share this to other students in this question. Any other students who have done this apart from Ved? Anyone? Please respond. Only Ved is responding. That's not fair. Everyone has to give ITJ? No. Okay, you at least tell me the problem was good, easy, difficult, medium, bad. What do you think, Ved Prakash? Was it a difficult question? How much time it consumed?
After, after the explanation, it was easy.
Okay, after explanation, it was easy.
Yes, sir.
Okay, this is the approach. The isothermal compressibility of water is given, which is given as K is equals to 1 by V with a negative sign, 1 by V, del V by del P, del V by del P. Why negative sign is there? Since you know, I mean, compress rate of change of volume with pressure. So rate of change of volume with pressure is always what? Most of the substances, it is negative. When you apply the pressure, the volume is definitely going to change. So this quantity del V by del P is going to be negative. Is that clear understanding? समझ आ गई बात? Del V by del P, rate of change of volume with pressure for all of the substances are negative. Now, don't tell me this is not in our syllabus. Anyone applying common sense, you can understand that if you apply pressure, the volume is going to diminish, going to be lesser. So that is why del P by del V by del P should be negative. Negative and negative will be what? Positive. So K is expressed as a positive number, and this is called isothermal compressibility. Okay, so this is isothermal compressibility, and you can see the value is 4.9 to 10 to the power minus 6 per atm, which means that it is a very small value with the range of 1 to 25. So from this, what you can get, you know, W is equals to minus PdV, and now you can write dV is equals to K into V into dP. So you will substitute this value. I mean, dV is equals to this value. You will substitute into the expression of PdV, and W will become positive sign के साथ K dV into PdV. You integrate this process from 25 to 1 atm, and you will get this answer. So that is work. How important this question is? Compare this work with the work of the gas, and you can see that this work is very, very small as compared to the gas. Okay, how it can become important in ITJ? So ITJ is never going to ask you, have never asked it, but sometimes they can ask you this question. Why? Because if you're compressing and this is the work, normally you ignore this work. But suppose I give this pressure is to be 10 to the power 5 atm. If I compress it by this much pressure, then what is going to happen? Then this work is going to be significant work. And then immediately this question will become a very interesting question in the first law. So a slight twist it always can give. It can give you isothermal compressibility, and then you can calculate the work, even work of, performing on the liquid. Once you get this work, your internal energy will change even at constant temperature. Okay, so that is a base of this particular part of this question will make you prepared if some twists is there in some problem of thermodynamics, because they are bored by asking ideal gas processes so long. Sometimes back 5 years back, they were asked something about the liquid, and most of the students faltered. So mostly people don't understand the difference between liquid and gas. When you apply pressure on a liquid, normally you do what? You take it, this work done, work performed is equals to 0. But you can see here, work performed is not 0. This is very less as long as the pressure is less. But if pressure is large, suppose if I take the same question from 1 atm to 1000 atm, then what is going to happen? Substantial amount of work is going to be done. Once you start doing the work, then internal energy will be what? In that scenario, whatever heat you have given, if you have not given any heat, in adiabatic condition you are performing this, then that will become delta U. Once you get the delta U, then I can also ask you what is delta H. Think about it. What will be delta H in this process? Anyone who respond? Can you find what is the delta H in the process? If I take it to 1000 atm? Anyone? Ved Prakash, let's usual. You're only leading the case. How you will calculate delta H? This is liquid. I'm applying pressure to 1000 atm. Same question. Adiabatic conditions.
Do we know delta U?
No, you don't know delta U. That is the only information given. You're just compressing this liquid. That is it.
With
and
same pressure or
from 1 atm
changing?
to 1000 atm, 1 atm to 1000 atm.
Did we apply directly 1000 ATM or slowly increasing?
Doesn't really matter, but slowly, let's take it slowly. I have increased it, but doesn't really matter. Why it is going to matter? Do you think that it is going to matter?
I mean, we can apply the 10 CP.
Okay, okay, I got it. Understand. But you applying it gradually. Take it like you're applying it gradually, because this is integral form. Integral form is pressure is gradually changing. So let us use this phrase that the pressure is gradually increased. Okay, very interesting. You have given a clue to another problem, that if pressure is immediately increased and pressure is gradually increased, what will happen? Okay, done. In these two cases, there will be two different scenarios. How you will approach that? If you are immediately increasing the pressure, then that will become P external. And then you will find the delta V by applying this. Okay. So you will eventually come to know that if you have applied this pressure, somehow this volume will definitely change to this value. So in this case, that will be W irreversible, and that is equals to delta U. But if you're gradually increasing, then you will do what? Then the work will be here, whatever we have calculated will be to gradual increase. You're absolutely right. Okay. So in these two cases, delta U will be slightly different. I do agree. Can you tell me which will be more, irreversible work or reversible work? Ved Prakash?
Reversible will be more
No,
magnitude.
irreversible will be more. Because in irreversible, you have applied the pressure immediately, and then that volume
Yes, sir.
change takes place. Are you convinced?
Yes, sir.
Yeah. So definitely irreversible work would have been more. Anyway, so you will calculate by these two methods what? Delta U. And once you get the delta U, what is delta H? Delta H is equals to delta U plus P2 V2 minus P1 V1. So you already know what is P2. You already know what is V2. You will know what is P1, and you will know what is V1. So in this question will become a fantastic question of chemistry by just giving the data. So whatever questions I have given, you can build very outstanding questions based on this, which will be quite new. And in coming time, they're going to ask in ITJ. That is why I'm taking only these questions. Clues are given. That's about question number 13.
Sir, how are we calculating delta U?
Delta U, simply delta U is equals to what? Delta U is equals to Q plus W. And we know that we have given the condition Q is equals to 0.
Okay, sir.
Okay. Another, if you really want to make it interesting, we are not going to go beyond any further. Okay. Because then a very interesting point is, suppose I conducting it in isothermal condition. If I conducting in isothermal condition and I am applying on the pressure, applying pressure on this one, volume is going to change. So there is another very famous constant in physical chemistry, alpha, which is 1 by V by del T at constant P. And you very well come to know that at constant pressure, volume may change. With volume change, temperature may change. Okay, sorry, at constant temperature with pressure, volume may change. So if you have this alpha, so you will also come to know that no, sorry, no approach. Sorry, that approach is not there. Sorry, extremely sorry, because temperature is held constant. So in that case, if I say that no, the adiabatic conditions is not there, I have given some heat to it, so temperature also increased. So in that case, Q will not be 0. Then question will be very interesting. And this question then will become what? You will calculate delta U and then delta H. Let's move ahead. There is a correction, because otherwise you can solve the problem. The cubic expansion coefficient of water 293 Kelvin is 2.1 into 10 to the power minus 5. Okay. Calculate approximately the work attending the heating at one pressure of 1 mole of gas from 288 to. This is also a very interesting question. Here you're talking about a liquid you're taking and you're heating it. And by heating it, you know that volume is going to change. If volume is going to change, what is the work performed in this one? So we try to calculate this with alpha. I don't think that we need to explain it after 13th question. It will be wastage of time. Very similar approach, and you can do it. Have you done it?
Yes, sir.
Okay, good. This question is also pretty straightforward question. These two questions are very interesting. So I would like to ask any one of you who have solved this question number 10. Question number 10. Anyone? Ved Prakash, आपने solve किया?
Yes, sir.
You got the answer?
Yes, sir.
Okay, tell me the approach. Crux of this problem.
First, I assume the process is happening against constant pressure, and I'm ignoring the leaking of moles from body.
You are ignoring the leaking of mole from the body.
I assume a container in which similar process is going on with constant external pressure and expansion is happening. So using
Very
that, I
good.
can calculate final temperature.
Okay. Very good. So what kind of process was this? Irreversible or reversible?
Irreversible.
Very good. So the crux of this is that it is a irreversible process. And since it is a irreversible process, you can see that this is the condition I have written. So this is the solution. See, however, whatever way you have done it, I've done it like this. So NCV T2 minus 294. T2 is the temperature at temperature which will attain. So if you just open the bottle, this is just like a irreversible adiabatic process. The gas will expand. Gas will expand, of course, under low pressure condition. So temperature of the gas will drop, and gas will also leak. So don't worry about the leakage. Whatever gas is going out, let it go. But whatever will left, the temperature will be less. Just think about it. That is the only point. So we can use this equation to get the value of T2. But let's confirm, because I need some help of yours here, because I think that I have done some mistake here. So I am not kind of verify it. But have you got this expression? Can you confirm?
After delta U, I directly substituted. So this part I don't remember.
Okay, you directly substituted what? How you will find?
Values of A and B2
Okay.
from delta U.
Okay, you calculated V2. I think by calculator you have calculated V2, na?
So
See this
B2 they
process.
given.
Of course, V2 is given, and V1, V2 20 decimeter cube and 60 decimeter cube is given. V2 in given, but P1 and P2 are not given, na? And this is the van der Waals gas. How do you know the P1?
Using van der Waals equations.
Okay, using van der Waals equation, using A and B. So you numerically calculated it, na?
Yes, sir.
Okay, tell me, see this solution, and quickly tell me, all of you, it's open to you. See this solution and see if you can find anything wrong with this one. Have you got delta U by delta V at constant T is A by V square? Should I show you? Del U by del V at constant T is equals to A by V square.
Yes, sir.
Confirm karo. Yes, is it all right? So dW is equals to minus PdV. So minus PdV is equals to RT upon V minus B into dV plus A by V square into dV. How I am writing this? Can you understand? dW is
Yes,
P.
sir.
And is this expression is all right?
Yes, sir.
I don't think there is any mistake, because P is equals to RT upon V minus B minus A by V square. So negative sign, all right. देखते जाओ, बताओ. So this step is all right. This step is all right. So this step is also all right.
Which steps?
And next step, which I have,
Yes, sir.
it's all right. Okay. So next step is all right. Then delta U. See this step. Delta U is equals to NCV dt plus A by V square into dV.
Yes, sir.
It is all right? Done. So if that is the case, then do you agree that du is equals to, since the process is isothermal, minus A into 1 upon V1 minus 1 upon V2 minus 1 upon V1?
Yes, sir.
Good. So Q is equals to delta U minus W. This expression is also right.
Yes, sir.
And then this will become delta U is equals to this. Already we see, and W is equals to, you already see from this step. So can you see that Q is equals to RT ln V2 minus B upon V1 minus B? Is this step all right?
Yes, sir.
All right. Then delta H is equals to delta U plus P2 V2 minus P1 V1. See this, what I have written. Is this step also all right? This is P2 V2 and this is P1 V1.
Yes, sir.
If this step is also all right, so putting the value of delta U, what I am getting a very interesting term, minus 2A 1 upon V2 minus V1 plus RT into this. Confirm, is it the case?
Yes, sir.
So you have to put the values to get the answer. So initially I thought this A 1 upon V2 minus 1 upon V1 term is going to cancel, but I found it very interesting that it is not cancelling, but rather it will become 2 times. So I could not get time to, maybe some sign mistake I have done. So you please check. That is the solution I've shared. Please check if it is all right. It's a very symmetrical problem then. Getting it? So it is
Yes, sir.
advisable to do it like this. So in any chemistry problem, get to the last step, and then if you do it, then you probably get the answer. Very good. Next question was develop an equation of this one. We have already done it in the class. So you just have to put the value and get the answer. And that was the expression. The last class we have done it, if you remember. Next question was, that's very easy question. Temperature scale conversion. This question is also very easy. And the second part is, since the enthalpy is a state function, there will not be any change. Answer to this one is 31% and none. Question number 5. Question number 5 answer is 31% and none. Check your answers. Next question was, find the boiling point of water 2 kilometers above the sea level. Have you done it? In such of type of questions, you can also use the calculator to save the time, because right now I told you we just have to go for, how many of you have done it? Ved Prakash, have you done it? Shreyash? Anyone else? Ved Prakash, have you done it?
Yes,
Got the answer?
yes, sir. 366.8.
Yes, absolutely right. 94 degrees centigrade. 94 degrees centigrade. All right. So I think that this solution is here. And I think it's pretty straightforward question if you got the answer based on barometric formula. Based on barometric formula. This question, third question, is a theoretical question. If somebody want to ask some discussion, then I'm very open to it. See, in this question, the theme is there that A upon V square is the interaction term. A upon V square is kind of, pressure correction term. So it has a dimension of pressure. Very interestingly, if you just multiply it by V, it will become A by V. This A by V term is basically, intermolecular interaction energy. This question is about the understanding of enthalpy. Okay. This question is about the understanding of enthalpy. So idea of this question was that we very well know what is enthalpy. If you just ask what is the difference between enthalpy and internal energy, then we know from thermodynamics why this question I have taken. We know that U is equals to U translational plus U rotational plus U vibrational plus U intermolecular interaction plus U miscellaneous. And this U miscellaneous is a constant term. This is if we talk about a gas. Similarly, if we talk about the liquid, we can also say U liquid, and this is intermolecular interaction of the gas. Similarly, for liquid, it will become what? U translational plus U rotational plus U vibrational plus U intermolecular interaction of the liquid and plus U miscellaneous. And this is also a constant. So if you talk about H2O gas and you talk about H2O liquid, if you take the difference between them, suppose H2O liquid is changing into H2O gas, and we want to find out the enthalpy change. So we will call it H of gas and we will call it H of liquid. So this H of liquid is equal to what? H of liquid is equals to U of liquid plus P into V of liquid. And H of gas is equals to what? U of gas plus P into V of gas. So the question is, what is delta H? So delta H vaporization is equals to H of gas minus H of liquid. Now, very interestingly, if I write H of gas, then all the term U translational, UT plus U rotational plus U vibrational plus U intermolecular interaction of the gas plus constant energy plus P into V of gas minus U translational plus U rotational plus U vibrational plus U intermolecular interaction of what? Liquid plus constant plus P into V of liquid. We can write it like this. Now, under these scenarios, what do you think? U translation of the gas and liquid should be same or different?
Same.
Same. Very good. So we can cancel it out. Rotational should also be same. We should cancel it out. Vibration should also be same. We should cancel it out. Okay. Now the constant and constant will also be the same. You should also cancel it out. So you left with what? You left with U intermolecular interaction of the gas minus U intermolecular interaction of the liquid and plus P V gas minus V liquid. And in fact, you can also ignore this V liquid tending towards 0. So that is delta H vaporization. Okay. And which comes out to be what? Now this gas, we can estimate it like this. A of the van der Waals constant divided by molar volume of the gas. Okay. Minus A, and this is molar volume of the liquid. And plus P into V gas. And this P into V gas is going to be what? RT. Now look here carefully. So this V liquid is very small. So this quantity is going to be a very large quantity. So basically that you can call it is approximated to delta U vaporization. That's very interesting. So we can say that delta U vaporization is just that energy which is needed to overcome the interaction between the gas molecules. So that is the idea of this problem. And you can see that this time delta U vaporization is not coming out to be exactly equal to calculated by the formula. So there is some gap. That means van der Waals equation is not that perfect. A value is not that perfect. Agar ye perfect hota, so this A value is, if it is perfect, then you would have got this delta U vaporization is equals to this. That was the idea of the problem. I hope you're getting it. So basically what delta H and delta U, what is the difference between delta U? Delta U is just the energy needed to overcome the intermolecular interaction. That is it. The crux of this is this theoretical point. Understood? समझ आ रही है बात जो मैं बोल रहा हूँ? चलिए भाई, रिस्पॉन्स आप लोग का बहुत ही बढ़िया रहता है. चलिए, next question is very simple. And then first question, have you done it first question also with Prakash?
Answer is not matching.
What answer you are getting?
162.
162. It is 46 ATM. So what you have done, I don't know. So please share your solution. It will be very interesting to see. But I have shown you that equation I have given. This is equation of state of a liquid. So we have just done this. Do you see the solution? So I have calculated it. You just try it. Just write the kernel of this. Okay, understood? Take a snapshot of this and try it. It is approximately 46 ATM. Another very interesting thing, this question can also be used to calculation of enthalpy, because you see what is happening by increasing the temperature by 10 degrees centigrade. If I give you the CV of this process, because this is happening at constant volume, by the CV, you can get what? CV into delta T is going to give you what? Delta U. Since this is a constant volume process. Now, what will be the delta H? Delta H will be delta U plus, in this particular case, you can clearly see that same volume pressure is increasing, V into P2 minus P1. So that will also be a very interesting question, basis of this very interesting question. The delta H is equals to, if I ask you what is delta U in the process, I just have to give you what delta H of the process. I just have to provide you the CV. And if I wish, I will not also provide you CV. Why? Because for water, everyone know that CP and CV is very similar. CP and CV is very similar. So in fact, if I can ask you in this question, so find delta H, that question is also very interesting. And you can easily get the delta H. How you can easily get the delta H? Because delta H will be then CP of water is equals to what? Specific heat of water is equals to 1 calorie per gram per degree centigrade. So that comes out to be 4.2 joules per gram per degree centigrade. Okay. And now 4.2 per gram. So for 1 mole, it will be what? 18 into 4.2. So delta CV you can already calculate from here. 18 into 4.2. That will be CV. CV into delta T will give you the value of delta U in the process. And you can also calculate delta H. That could be a variation of this problem. Okay. So these are some questions on thermodynamics. Now, you understand? Everyone, any doubts here? Someone was speaking. I could not see all the things, and chatting I can also not also see. So it's totally blind process. No hand raised are there. So I find it really difficult to evoke a response. Anyway, so what do you want me to discuss now? Should I
Sir,
take?
here,
Yeah. Who is
sir,
speaking?
here, Ved Prakash.
Yes, Ved. Bolo.
Here we took T minus T naught as 10. Shouldn't it be 35?
35? 10 degrees centigrade we have increased, na?
But T naught is 273.
Okay. I got it. I got the difference. I got it. I got it. That is why you're confused. But basically it is delta T. You got it what I'm saying? So there is a mistake. There's a mistake. I think that there's a mistake in the problem. You don't understand because you apply your because we are taking it from 25 degrees centigrade, na? So this T naught should be at 25 degrees centigrade. If it is, it's all right. This is, you're right. Okay. You're right in your own might. So I should have given the problem like this, that from V naught naught, it has been increased to this one. Basically, T naught and T is difference between what? You're right in that sense. So then one thing is there. What about this 25 degree original temperature? There is no original temperature in the equation. And if there is no any original temperature in this equation, how can this will be an equation of state? So that is the problem. I think there is a mistake, slight mistake. We just want to give it, alpha into T. And the difference in T, that means what? Delta T. Okay, sorry for that. That is why. But rest of the approach, I think you're right. Only thing is delta T you're taking different, na? That is it?
Yes, sir.
Then all right. I got a confusion. Fantastic. I'll make this correction in this problem. I'll make this correction. Sorry for this. Very minute point. Fantastic. Good. So I like this discussion, and you have done it. I think many students have done it, but they're not interacting. So, beta, aap logon ko, I just don't want to demoralize you. If you are interacting, then I am going to give you some good questions. Otherwise, usually I don't know what you have done, what is your expectation. So you can come up and tell me some easy problems we can take, some different problems we can take, and all this. Okay. So those who are responding can only get these answers. Anyway, so let us try a few more problems. And ionic equilibrium you have asked me. So I've planned the next discussion will be the ionic equilibrium. And I have given some problem here. So for sound knowledge in the ionic equilibrium, you need to have these kind of questions. So I will share these questions today and try to do some problem. Let us try question number 2. Let us try question number 3. Okay. Every one of you try question number 3 and try to solve this problem and get the answer. Question number 3. Consider an equilibrium A plus B changing into C plus D, and B plus C is in equilibrium with E. K equilibrium for the first reaction is 5 into 10 to the power 9, and K equilibrium for the second is equals to 1. Starting with initial concentration of 1 mole each of A and B, find the equilibrium concentration of each species. I will share this file with you, but now in the class, let us try this question.
Sir,
Yes.
A is 2 into 10 power minus 5, and B is 10 power minus 5, E is 10 power minus 5, C and D are 1, 1.
Very good. Absolutely fine. So what was the idea of the problem? You got the idea?
Yes, sir.
Fantastic. So just confirm that how you have done this. What is your method of doing the problem? Adding a page here. Just confirming how you have done this. So I would like to do this problem like this. Starting with initial concentration 1 mole each of A and B. So I have to start with A, B, C, D. So for generally I used to do this problem. I don't know how you have done it. I will try to do the problem like this. A, B, C, D, and E. Since it is simultaneous equilibrium, it is easy to trace it when you have these type of columns. I have initial amount of A was 1 and B was also 1 mole per liter. So what I have done with, I will assume that this equilibrium constant is very large. I can see that this equilibrium constant is very large, which is telling me that take this reaction completely into the forward direction. I don't know how you have done. So what I will do, I will take it as -1, -1, and I will add here +1 and +1. And I will start my problem from here, 0, 0, 1, 1. I will start my problem from here. From here now, I will take this equation backward. So I will assume that, let us assume that x of C has gone, x of D has gone, and A and B has been formed. So now in the next equilibrium, B and C is reacting. So B will react and this will become x minus y, C will become x minus y, and E will become y. So I will put this equation like this, 1 minus x, 1 minus x minus y, this is y, and this is x minus y, and this is x. Now based on this, some intuitions are there. The intuitions are this, 1 minus x should be nearly equal to 1. And 1 minus x minus y should also be nearly equal to 1. That will my assumption. Clearly, I will assume that x is very, very much less than 1. That is my assumption. On the basis of this assumption, I can only proceed to solve the problem. Another assumption you can see here, that since y is coming out of the x, I think that x is going to be greater than y at any cost, because x should be greater than y, otherwise this quantity will be negative. So another intuition I have is x should be greater than y. Now based on this, I can go and establish the first equation, and which is, first equation is 5 into 10 to the power 5 into 10 to the power 9 is equal to the concentration of C and D, which I have taken as 1 into 1, and the concentration of A and B, which is x into x minus y. First equation has been set up. The second equation is B plus C is equal to E. E is equals to what? Y. We can see this is x minus y and this is x. So the second equation is 1 is equal to y divided by B plus C, which is x into x minus y. Sorry, x into 1. So from there we can easily get that y is equals to x. And if y is equals to x, then that is going to be a...
So it should be x minus y.
Okay, x minus y. Yes, you're right. So x minus y, and this is b, and c is equals to 1. Yeah. So from this we can get what? X minus y is equals to y, and which gives us x is equals to 2y, and this means y is equals to x by 2. Substituting these values, we will get, y is equals to x by 2. Substituting these values, we are going to get x is equals to y by 2. Now we can put it in this equation. So 5 into 10 to the power 9 is equals to 1 divided by x, and of course x minus y is equals to x by 2. X minus y is equals to y, which is equals to x by 2. So we can solve this problem, and that is going to be x square is equals to 2 by 5 into 10 to the power minus 9, and that is it. Ho jayega problem solve the way we have solved it. So basically we are going to multiply it by 2 multiplied by 2. That's a very simple problem, and this is 2 into x is equals to 2 into 10 to the power minus 5. Y is equals to 10 to the power minus 5. So why I have taken this problem? So all the students who have joined this problem, who have joined this class, this is how one should start the ionic equilibrium, because ionic equilibrium is all about taking approximations. And see, if you try to solve this problem in some other way, that is going to be a very difficult problem. Clearly see your approximations are absolutely valid, because you have written 1 minus x minus y is nearly equal to 1. You are absolutely right. You have written 1 minus x is equals to x. Are your approximation justified? Yes, of course they are justified. So this is the idea. Most of the ionic equilibrium we used to do this. Otherwise, this problem need what? A computer, a software which can solve a cubic equation, maybe x to the power 4, maybe x to the power 5. You will get the exact answer, and you will be surprised to know that the exact answer what you are going to get will be very similar to this answer. Try it. If you want to try, you try it. Nowadays, you can get Wolfram mathematics, math equations are there. You get also GeoGebra. You can immediately get in fraction of seconds the real answer. But nobody interested in real answer. Everyone is interested in what? Approximate answer. That is the first question which I would like to give you. So similar such questions are there. If you wish, I'll share this file. Do 1, 2 or 3 more such questions, like question number 5 I have marked here. Just do question number 5. Also, just do question number 7. Okay, that is it. And maybe question number 8. Do such kind of questions. I'll share this file after the class. Okay. And please come up in the next class with trying these questions. Next is, I would like to ask you here, let's try question number 3. The pH of 1 liter HCl solution is 5. How much water should be added to make pH of solution 6? And the B part is more interesting. How much water should be added to make pH is equals to 6.6990? That is it. Anyway, I just want to see here how you have solved it. Avinash?
First, I have taken 1 liter solution and I have calculated number of moles of H plus from HCl. Then I assume that L liters of H is added, means water is added. From each 1 liter, I'll get 10 power minus 7 moles of water. So L into 10 power minus 7 moles of water I'll get from H plus will be given by water. I added both and divided by the number of liters, which is L. And from there I solved to get L.
Okay, so your answer is 100 by 9. 100 by 9 liters.
Yes, sir.
Beta, one thing is there, when you're adding water, water's equilibrium is also going to be disturbed. So every time water is not going to give 10 to the power minus 7. Water is a weak acid, understood? Water is a weak acid. But this time the solution is very dilute. So in that scenario, the H plus which is coming from the HCl and the H plus which is coming from the water, they will become comparable. What do you think? The HCl is not going to affect water? Definitely it is going to affect. Because water is extremely weak acid. So it's extremely weak acid. If someone is adding H plus from outside, then that extremely weak acid is also going to get disturbed. So whenever in ionic equilibrium, pH is going less than 6, be alert. Be alert. Because then water is not going to give 10 to the power minus 7 flat. In fact, water never gives 10 to the power minus 7. Okay. So this approach is faulty, and try to correct it as soon as possible. Otherwise, never touch such kind of questions in examination. That will give you the negative marking. Okay. If you don't have time, any question, if it is coming less than 10 to the power minus 6, don't touch it until you are expert. Otherwise, you are going to lose marks. Got it? Which center you are studying, beta?
Kukatpalli, sir.
Yeah.
Hyderabad Kukatpalli, sir.
Okay. So that is my advice. I'll discuss the solution. Then if you feel like it, you are comfortable. That is very easy question. But till you are not confirmed, don't try. Okay. Done. Yeah, anyone who has done this, thank you for opening and interacting. That's a great thing. That's a great idea. I'm going to explain to you. Ved Prakash, have you done it?
First one, 5 into 10%.
How much? How much? Please tell me once again.
5 into 10%.
5 into 10 to the power 6. Just check. Let me check the answer. Question number 3, na? It is 65.667 liters. How much water should be added to make pH is equals to 6? And additionally, this was a 1 liter, was initially 1 liter, and pH was equal to 5. So I think that one thing is sure, that in this, there is 10 to the power minus 5 H plus ion, and which is close to the acid HA. HA must be there, and its concentration is 10 to the power minus 5 mole in 1 liter. So I will start from here. So pH becomes what? pH becomes 6.6990. That means H plus concentration is 10 raised to the power minus pH. 10 raised to the power minus 6.6990 equals to 10 raised to the power minus 7 plus 0.3010. So that is coming out to be 10 raised to the power 0.3010 into 10 to the power 7, 2 into 10 to the power minus 7. This is the final H plus ion concentration. Now I will assume that let V liters have been added. So V liters have been added in 1 liter. So let us call that total volume is equals to V liters is a combined final volume, including this 1 liter. So in that scenario, you got the answer? Is it coming out to be 65.66?
Yes.
Okay. बच्चों बाकी लोग देखो कैसे करेंगे. Now this is final liter. Now what are we going to do here? We have to understand this, that at equilibrium the total H plus concentration must be equal to total OH negative concentration plus total X negative concentration. I'll explain you. That is the simplest approach you have to do. Now since H plus is going to be 2 into 10 to the power minus 7, OH negative will be definitely 1 by 2 into 10 to the power minus 7. Concept. Try to understand this, Avinash. And plus this X negative, I don't know, but I will put it like this, that this X negative must be, how many moles were there initially we have taken? Initially there were 10 to the power minus 5 moles. So 10 to the power minus 5 moles were there, but now the volume has become V. That is its concentration. You can see this is 3 by 2 into 10 to the power minus 7 is equal to 10 to the power minus 5 by V. So V is equals to 2 by 3 into 10 to the power minus 10 to the power 2, which is 200 by 3. Is it 66.6666 liters and minus 1? So basically you have to add how much? 66.666 minus 1 is equals to 65.666 liters. So don't you think that's a very easy question? Avinash, do you understand the solution?
Yes.
So never try to take, if you are comfortable in this, I don't, if you're interacting, I'm not going to solve it like this. If you're interacting, I'm going to solve it like a proper problem. Okay. So like this one, that this Hx has broken into H plus plus X negative, that will give you more feel. But since you're not interacting and water is also breaking down and it is giving H plus plus OH negative, do you agree that is something like this will happen? So in this scenario, we could not take 10 to the power minus 7. No, we'll take it A. And we don't know this A. And if A is coming from there, then A is also coming from there. And now this Hx is also going to give, the concentration was 10 to the power minus 5. And it was in 1 liter. But you divided it by V. It is going to completely dissociate. That is going to give 10 to the power minus 5 by V and 10 to the power minus 5 by V. Okay. But this will become this plus A and this will become A. So you basically solve this equation, 10 to the power minus 5 by V plus A into A is equals to 10 to the power minus 14. One equation is like this, and we know that this value is given. How much is this? This value is given is to 2 into 10 to the power minus 7. You can also solve it like this. And I think this is going to give you much more feel. Do you agree, Avinash? The second
Yes.
method which I have solved is going to give you much more feeling of this thing, what is happening. But if you're not going to get feel of this, sometimes a student want to ask me, I'll explain it like this. I'll not explain it like this. Okay. But if you're not getting anything, the last moment I would say that use the charge balance, get the same answer. So it's a very interesting question. Similar questions will be taken up like this. Okay, then. Similar question is this. How much water should be added in 100 liter HCl solution having pH is equals to 3 so that the pH of the resulting solution is 6.9. So I will share this file. You can try some other questions like this. Let us try one more question here. Can you try question number? These are series of questions. If you can solve all these questions, you are champion in, weak acid calculation. So you can try some special questions in this one, like D. In fact, if you can try all this, that's very good. D, like C, and like E, and in fact, like F also. G. In all cases, you also have to get the alpha, degree of dissociation. So suppose a weak acid is there, the concentration of weak acid is 2 into 10 to the power 3, and K of the weak acid is 10 to the power minus 3. What will be the H plus concentration and what will be the alpha? Similarly, so how many questions are there? You can see 1, 2, 3, 4, 5, 6, 7, 8. These all 8 questions have something special in them. Okay. If you can solve all this question, I can give you guarantee that nobody can beat you in the weak acid calculation. And if you are champion of the weak acid calculation, you are champion of the ionic equilibrium. At least 60 to 70% of the problem you can do. Okay. So try this question also. Question number C. Let us begin with question number C. Can you do it? Okay. We have less time now. So I will share this file. In the next class, I'm going to discuss ionic equilibrium. And if you have any basic queries in the ionic equilibrium, then you can ask there. These are some questions, just filling the blanks into this one. Similarly, some interesting questions are there. Mixture of weak acid calculations are there. I'll give you this. And similarly, mixture of weak acid and strong acid calculation is there. And simultaneous equilibrium. A very limited file is there. Some more questions I'm going to share, which is related to buffer. And they're very unique questions. They're not the usual questions. And they are going to be asked in ITJ in the coming years. They have not been asked, but they are going to, maybe this time, because they know that you have done all kind of problems, hydrolysis problem, and all these things. Okay. So before I move ahead, I'll just try to give you an outlook of what is going to be the theme of the next class. In the next class, if you wish, I'm going to tackle few more questions like this. We know that NaHCO3 is amphiprotic salt. And we know that the pH is given by half pKa1 plus pKa2. I would like to ask you assumptions taken to get this answer. Try to get the understanding of this. Anyone who can tell me? Ved Prakash, what is the assumption taken to solve this problem? Anyone?
The dissociation of HCl minus is very
Yeah.
less.
Just repeat. Can you uncam and tell me? Because then I can get more. Can you uncam if you're not comfortable? Yeah. Yeah. Tell me, what is the assumption taken? You're not audible probably.
HCl minus concentration is not changed during equilibrium. C minus X is approximately C.
Okay, I could not hear you, but are you telling me that H is CO3 negative concentration? It is going to be broken into H2CO3 and also CO3 2 negative. So isn't it the assumption is this, that if it is going like C minus X minus Y, it is X and it is Y. Okay, all right. So your assumption is X is equals. Are you saying this? Hello? Your internet connection is weak, it seems. My internet connection is weak, it is showing. Am I audible?
Yes, sir.
Okay.
Yes,
So
yes.
is that the assumption that x is equals to y?
Approximately x equal to
Approximately x is equals to y. Fantastic, fantastic. Yes. So if approximately x is equals to y, you try to solve this problem like this. HCO3 negative plus HCO3 negative changes into CO3 2 negative plus H2CO3. So you can write it like this, twice of this, twice of this. And then you write C minus 2x and you take here x and you take here x. And the equilibrium constant is equal to K2 upon K1. And you simply solve the problem. You say that K2 by K1 is equal to x square upon C minus 2x. And you simply solve the problem like this. So what you are doing? You're doing that x is equals to y. If x is equals to y, then pH should be equal to what? 7, isn't it?
isoelectric point type.
Yeah.
Like isoelectric point is the midpoint of the K1 and K2.
Yeah, of course, like isoelectric point. You're taking reference of the isoelectric point. Basically, from this we explain isoelectric point. So I am asking a very point blank question. From this we explain isoelectric point. Okay. So don't you think that this assumption is faulty? And if it is not faulty, how beautiful this assumption is. How you arrived this assumption. Is there any theory for it? So one more thing. Why I have not done this? HCO3 negative is changing into what? HCO3 negative plus H2O, it will break into H2CO3 plus OH negative, and HCO3 negative plus H2O will at the same time will form CO3 2 negative plus H3O plus. And you very well know the equilibrium constant of this one is Ka2, which is approximately 10 to the power minus 10, and this equilibrium constant is Kw upon K1, which is 10 to the power minus 14 divided by 10 to the power minus 5, which is 10 to the power minus 9. So it is absolutely sure that OH negative will be more than H plus positive at any cost. So if this is C, this is also C, this is minus X, this is minus Y, this is X, this is X, this is Y, this is Y. One thing is absolutely sure that X is going to be greater than Y at any cost. Do you agree? And the solution's pH is going to be more than 7. But we have taken this assumption, and what we have done, we have written here OH negative plus H plus changing into H2O, and written a line over here, added all this equation, and adding all this equation, we have cancelled all this thing. Twice of HCO3 negative is breaking into H2CO3 plus OH negative, and we have written not like C minus X minus Y, we've written C minus 2X. That is correct and that is incorrect, but we are writing incorrect thing. Why? How it is justifiable? That is the thing. Why I'm asking this? Because everyone is using this formula. Maybe the better idea is this time they are going to break this formula. You can see that there is no relation to the concentration and all this. This is also bakwas. Anytime I'm going to make a problem in this concentration, like I make a problem now, isoelectric point, 9.9 ml you have added, this will go down. So we just try to understand this. Same this case, CH3CO negative NH4 positive. We are so lucky that K and KB is equals to equal. You're so lucky. And that is why when the NCERT writes this, that CH3CO negative plus NH4 positive plus H2O breaking into CH3COH plus NH4OH, you write simply conveniently C minus X, C minus X, x and x. But what about if k is 10 to the power minus 9 and kb is equals to 10 to the power minus 5? Is this approach still workable? What is your gut feeling? Is this approach still workable? Yeah.
Yes, it probably gives a more balance that H plus can go forward. So, yeah.
So why this approximation? So you want to say that whatever be the difference, still we can take x is equals to y. That's what you are saying, isn't it? Yeah. Yes. Yeah. So in next class, I'm going to see this. Okay. Whatever be the difference, yes, you're right. Whatever be the difference, x is very, very close to y. And in fact, in this case, the x is definitely going to be greater than y. No chance about this. But x minus y will tend towards h, and this h will tend towards 0. That's another fact. But this h will be this h is going to be very, very significant. That will be my theme of next class. That will be the final class in the ionic equilibrium, because there is only two kind of problems in ionic equilibrium. One, acid and acid together, acid and too many acids together, acid and water. Another, acid and base is there. When acid and base is there, they will fight. And when acid and acid is there, they are friends. Okay. So when acid and acid is there, that's a pretty simple thing. So what sheet I am going to share you will be acid and acid. All combinations of acid, strong acid, weak acids take together. Be champion in that. But when acid and base are together in the solution, especially weak acid and weak base, that's a very interesting thing. So there are only two cases in ionic equilibrium and can tackle all the problem. Okay. Regarding solubility equilibriums and all this, I can simply ask you a question. That could be my theme of this thing, that find solubility of a salt like AB2 solid, which is going into one A2 plus plus twice, sorry, A2 negative plus 2B plus, something like this. And here A2 negative can form two equilibrium. Suppose K1 of HA is equals to 10 to the power minus 4, and K2 for H2A is equals to 10 to the power minus 8. And if I can ask you, find solubility at pH is equal to, say, 6. Find the solubility at pH is equals to 6. Okay. So at the face of it, this question looks, dangerous, very dangerous. But once again, ITJ can ask, it's a very easy question. Straight when KSP will be given. KSP is equals to, say, 10 to the power minus 10. What will be your approach to solve the problem? Seems very horrible. That A2 negative will going to hydrolyze into what? HA negative, and then HA negative is further going to hydrolyze, something like this. So this is a question which is going to take approximately 30 seconds to solve, if your approach is good. How can you solve the problem? So this is also one such question I'm going to study. I'm going to take in the next class in the ionic equilibrium. These questions are very probable, and similarly some basic questions like this. When you solve complexation equilibrium problem, Ag plus plus NH3 chaining into Ag NH3 plus, and then Ag NH3 plus plus NH3 chaining into Ag NH thrice plus. The equilibrium constant is Kf1. This is Kf2. You call it like this. Okay. But you always try to solve the problem like this. So if you have doubts in these, sir, why we write it like this? C, and this is this is C1, this is C2, minus x, minus 2x, and x. Something like this. Why we do it? It should not be done now. Why?
Both KF1 and KF2 are very large. So,
Today you're not audible. Some problem is there. Yeah, Ved Prakash. Yeah, tell me.
Sir, KF1 and KF2 are large enough.
Yes. So can you explain why by being so large, what is going to happen?
So it matches.
Okay. You're right. You're right. Large enough. So if they're large enough, we can do it now. Idea is this: if this is small, we can always cancel out. If this is small, we can always cancel out. Okay, but if it is not small, you could not cancel out. This is the idea. So when to add to equilibrium and when not to add to equilibrium, this is the very only point which you need to understand. Okay, when to add and when not to add. These are the 2 points. So if you understand these 2 points, fantastic. Then your ionic equilibrium is under your pocket, under your belt. But if you don't understand this, then ionic equilibrium is definitely a problem. Okay, so get the processes clear. I think the Ved Prakash has been dropped due to some internet connectivity issue. So, okay, bachcho, anyone else try to take any other chapter if you wish. So I will take this. Okay, then, and next class I'm going to take
Not
this.
particularly any chapters.
Yeah, any chapter you want wish, or all the chapters just like going on some questions, brainstorming question kind of a thing, no?
Brainstorming questions.
Yes. Okay. So try this. I'll give you a few more brainstorming some questions and upload. There is a folder which I have already shared, and I have shared it with the Prasad ji. I have shared. You can take that folder. You can call him, and the folder will give access to the answer key and all this. The next day I've given the answer, so I will not give answer first day, but I'll give answer to the next day. So the file I'm going to share with you you will get the answer the next day. So you try one day, next day you get the answer. Okay, bacho, take care. Please be more interactive if you really want to wish to know, and we can get a lot of things, concepts clear, but you need to interact. Don't feel shy. Thank you very much for attending the class.